Okay, let's get in touch with our one and two-sided limits here and try to process what those are. Sometimes the values of a function f tend to go to different limits as x approaches a certain number from both sides. When this happens, we call the limit f of f as x approaches c from the right-hand limit, and from the left side it would be the left-hand limit. So quick little tutorial on the notation here. So when we talk about a function f of x, let me do a quick little sketch here. Okay, get a little color into this. Here's our graph of f of x, and we are going to approach c. So when we talk about the limit as x approaches c from the right, we're going to use that subscript plus or superscript plus. And that means as we approach c from positive infinity. So we're going to go from positive infinity and we are going to close in on c from the right side. Now a left-hand limit is going to have us use a negative superscript on the c, and that means we're looking as we head in from the left side. So I'm sure you probably know what this means for the existence of a limit. We said if a limit exists, it has to be unique, can't go to two different numbers. So we're going to reiterate that here with theorem number 3. A function has a limit as x approaches c if and only if, and that is a big thing to kind of think about. That little IFF there, that's not a typo. It means if and only if the right and left-hand limits at c exist and are equal. Okay, so that means if a function has a limit, then the left-hand limit and the right-hand limit must be the same thing as the limit as x approaches c from both sides here. Got the colors backwards, but you have the idea. Okay, so that's the idea behind one and two-sided limits. All right, so now this can be useful for investigating the behavior of certain things like step functions. And I know you looked at this in pre-calculus, and here's a graph of one at the bottom of this page. But just to kind of remind everybody here, with the step functions, one-sided limits can be useful to investigate those. And the greatest integer function is one that I know you looked at in pre-calc. And the greatest integer is the integer n, such that n is less than or equal to x. So the largest integer that you have that is less than or equal to the number that I hand you. So for 4.8, the answer is going to be 4. And for negative 3.3, the answer is going to be negative 4, because that's the biggest integer n that is less than negative 3.3. So working along with that, you take a look and you see the graph of the function. I guess what we could probably do here is maybe add in some more specific circles and closed and open circles, because that might help ring the bell on, oh yeah, I remember this function for pre-calc. So here's just like a little snippet of what the pattern would look like here. So let's see if we can find the left and right hand limits as x approaches 3. So there's an x value 3. So once again, a left hand limit comes in from the left. So coming from this direction, the limit as x approaches c from the left of the greatest integer function of x, that limit as we approach 3 is going to be 2. So now I've got to investigate the limit as we come in from the right side there, and the limit as x approaches c through the positives of this greatest integer function, it's kind of funky to write these brackets, is 3. So now you see we've got two different limits. So the limit at 3 doesn't exist, obviously, but the single limits do. Let's take a look at some examples on the next page here. All right, now you'll notice I've taken the liberty of making the graph of this messy function, and I can find the limits of each of these things as x approaches each of these numbers. So let's kind of take a look at it and talk about both a left-hand limit and a right-hand limit. So I'm going to make two columns here. One is going to be the limit as x approaches the c value from the left, and the other one's going to be the limit as x approaches the c value from the right. Okay, now as I go ahead and figure this out for each one of these numbers, I want you to note that this function has a limited domain from 0 to 4 inclusive. Okay? So we're not going to step out of that limited domain. So that means for x is equal to 0, I want to point out that as I come through the left here, there's no graph. The function doesn't exist because it's not defined for the domain. So I'm going to have to just simply say none for the limit as x approaches 0 from the left. And we could make that same argument for the limit as x approaches 4 from the right. Function is not defined outside that domain, so we're going to just have to say none because the function does not exist. You could also say the limit does not exist as well. Okay, so moving ahead, starting at 0, if I wanted to find the limit as x approaches 0 from the right, it looks like we're moving in toward 1. So I would say that limit is 1. If I want the limit as x approaches 1 from the left, well, as we're going in from 1, it's going towards an open circle at 0. But remember, that open circle doesn't matter. So that's just going to be a 0. As we approach 1 from the right, it looks like we're coming in on a value of 1. Okay? Now, as we approach 2 from both the left and the right, you will notice that we're approaching the same value of 1, even though the function is defined to be elsewhere. So it's probably safe to say those two limits are 1. So that means the limit does exist at 2. All right, you could probably make that same argument at 3, that in both cases they're approaching 2. And the limit as x approaches 4 from the right, or from the left side, as we get closer and closer to 4 from the left, we are going to be approaching a value of 1. Okay, so I want you to look at the bottom of the page here and look at this particular graph and take a moment and see if you can identify those limits. Pause the video if you would for our last little exercise here, and then let's see if you can find those limits, and we'll find the answers in just a moment. All right, now you see my answers here, and hopefully you will find that these weren't hard to find. As I approach 0 from the right, the function is going to 0. As I approach 2 from the right, I've got this gap. So the function is not going to be defined between 2 and 3. So it's going to be really hard for us to approach 2 from the right. So that's why I say the limit does not exist. As we approach 2 from the left, we're coming in on a y value of 4. So that means the left-hand limit doesn't exist, the left-hand limit is 4. The right-hand limit doesn't exist, which means that the limit itself doesn't exist. Now you notice that each of those had a plus or a minus indicating a one-sided limit, whereas this did not, indicating a two-sided limit. All right, last one here. As I approach 3 from the right, we're going towards a y value of 0. Okay, that's all I got, folks. Enjoy this, and we'll see you in class.